Hello friends, let us move on to the last topic in the third chapter, that is nothing but variables and keywords, which is the concept of using linkers. Linkers, it would concatenate or rather combine two programs. Anyway, first of all, we should understand how a compiler works, for which I would request you to look at the top left corner of the whiteboard, in which I have shown how the code gets converted from high level language to machine code, that is zeros and ones. The high level language is given to the compiler, which will convert the high level language to the assembly level language. That assembly level language would be given to the assembler, which in turn would convert it to the machine level language. We all know that computer doesn't only understand zeros and ones, that is, we have to give it to the computer in machine level language only. This is how our code would get converted to machine level language. The high level language would be converted to something called as assembly level language. That assembler would convert it back to machine level language. So you might be thinking, why do we need two things? Why do we need compiler? Why do we need assembler? Why can't we directly convert it to machine code? That is because even before compiler existed, even before high level language existed, assembler concept was already there. Even before 1970s it was there. Therefore, it was much easier for the programmers to convert it to write a code to convert high level language to assembly level language, and using the concept of assemblers which was already there, it would be converted to machine level language. And also there are a few other advantages which let us not go into that now. What we need to remember now is high level language would be converted to assembly level language through the compiler. This assembly level language given as input to the assembler. Assembler would provide or rather produce the machine code given to the computer. This we should know. Anyway, we would be using this concept later in our video. For now, let us look at... Sorry, I think there was a disturbance. Let us look at the linking part of the program. I have one program in which maybe I have the main function and some other functions I have, and I have called it as p1.c. And also I have another program which is called as p2.c. Say suppose p1.c is say 20 lines, and say suppose p2.c is say 10 lines. Okay. So I have represented p1.c in blue ink and p2.c in red ink. So if I want to link it, I should say gcc p1.c and then p2.c. If I say that in my Linux terminal, these two programs would be linked. If you are not using Linux, if you are using Turbo C, you can link that also, but there would be some other command. I am using Linux operating system in which there is a terminal. To link that, I should say gcc p1.c and p2.c. However, if you are using some other compiler or something like Turbo C or something, there also you would be able to link. You would probably have to Google the command or something. Anyway, that is not important. The command is not important. The linking is what we have to look at. The 20 lines of the first program and the 10 lines of the second program would be concatenated when I say that like this. In other words, P1 and P2 are linked together. Like this, in one program only both the statements, both the program's statements would be combined as I have shown below. And together it would be 30 lines that we know. 20 plus 10, 20 plus 10. 20 lines and 10 lines. Together it would be 30 lines. I hope this how the linking is done using GCC command we came to know. Anyway, either it can link it line by line like this, also it can link one after the other, or some compilers they would want to link such that all the variables of both the programs would be in one place and all the methods would be in one place. Like that also it can link. That is nothing but these lines of blue and red would be reshuffled a bit. However, that also would have 30 lines only, a combination of program 1 and 2. What I am trying to say is, after linking the given program, it may be sequential like this. First I will all the blue lines, then all the red lines, like that it can have. Or you can shuffle it a little. That is, all the declarations in one part and all the statements in one part. Like that some compilers might do. Both the compilers are right. It doesn't matter to us how the compiler does it. What we need to know is 20 lines code and 10 lines code we are linking, and we are getting the combination of that when we say GCC and the two file names. Like that we are getting. So this is the basic concept of linking, after which let us go to the theory where we would understand it even better. So now the compiler assembler concept comes into play. We already know that the compiler processes the code and gives assembly level code to the assembler. The assembler doesn't understand int a, or rather float b, or int add function, all that it doesn't understand. According to assembler, there are only two types of variables: strong variable and weak variable. So what the compiler should do is classify all the variables as either strong variables or weak variables. That is what I have written there. The compiler would export each global variable, or rather global symbol, to the assembler as follows. The compiler would export each global symbol to the assembler as follows. First one, it may export it as a strong variable, or it may export it as a weak variable. So if you ask me which all variables are exported as strong variables, if you ask that question, for all the function names are exported as strong variables. Not only that, all the initialized global variables are exported as strong variables. For example, int add is there. That's a function name. Add is exported as a strong variable. Then int z is equal to 10. That is an initialized global variable with initialization value as 10. So z is also exported as a strong variable. However, uninitialized global variables are exported as weak variables. For example, int z, that is an uninitialized global variable, that is exported as a weak variable to the assembler. Sir, okay, fine, but what is the use of this, you might be thinking. The use of this I will tell you. I hope until now I have been completely clear. So there is a certain rules for linking. Which files can be linked, which files cannot be linked. For that only we have three rules. So if the files, if the two files, they contain this multiple strong symbols, then it is not allowed. For example, in the global variable of the first file, in the p1.c, if I have a strong variable, say z, and in p2.c also I have a strong variable z only, that is not allowed. Anyway, I have demonstrated each rule by using an example. So multiple strong symbols are not allowed. Not only that, given a strong symbol, Not only that, the third rule says if there are multiple weak symbols, we can choose any one of the weak symbols. I know these rules doesn't make a lot of sense to you now, but once we go through the program, it would be completely clear to you. So this is the first program. The second program, fun2, it also has int main and return 0. That only it has. I mean return 1 it has. Anyway, when I say gcc fun1.c and fun2.c, you know what happens. Both the programs would be linked. In other words, whatever I've written on the right side, that wouldn't happen because of rule 1. What does rule 1 say? Multiple. After which int main return 0. I mean main is also a strong function only. Strong symbol only because it's the name of a function. So there are two strong symbols in foo.c, foo1.c. That is nothing but x and main. Okay. Let us move on to foo2.c. In that, I have int x equal to 1. It's a global variable and I am initializing a value of 1, which means that is also a strong symbol. And void f, one function is there. That is also a strong, f is a strong symbol because it's a function name. Function name are strong symbols, we know that. So when I try to link it, like how I want it, I have written on the right side. I want it to be like that. So I say gcc foo1.c foo2.c.